Okay, we have a compounded angle here. And note that cosine and secant are reciprocals, and sine and cosecant are reciprocals. So that tells me I should expand this. Right, cosine pi over 12, cosine of x, sine of pi over 12, sine of x, all multiplied by secant of pi over 12. Expand this, right, and we get sine pi over 12 cosine of x minus cosine of pi over 12 sine of x. Okay, and this is all multiplied by cosecant of pi over 12. Multiply it in, and remember that cosine times by the secant, if it's the same angle, it's going to equal to 1. So multiplying these two, we get 1. So we just get a cosine of x. Here we get, doesn't simplify, so let's leave it the way it is. Okay, again, cosecant times by sine will give you 1. So if you expand that, you get a cosine of x, okay, a minus cosecant of pi over 12 and cosine of pi over 12 and sine of x. So this and this will cancel out. Okay, and you get a plus. Okay, all right, we can factor that out, right? So that's sine of x, which is what we want on the other side, and we have now left over sine of pi over 12, and actually let's write that as a primary trig ratio. That's going to be a cosine of pi over 12 and a cosine of pi over 12 over a sine of pi over 12. To the bottom, the common base will be sine pi over 12 and cosine of pi over 12. The numerator, we actually get a Pythagorean identity. That's going to equal to 1. Okay. And this right here is actually half of, right, sine of double angle. So pi over 6. If you double pi over 12, you get pi over 6. Okay, so this is a partial expansion formula for the double angle of sine of pi over 6. So, almost done. That's also half. So this is going to be 1 over 4. 1 over 1 over 4 is 4. So we get 4 sine of x. And we're done. So make sure you follow this step here, from here to here. Just as a side note here, I'll write that out. That sine of pi over 6 is equal to sine of 2 times pi over 12. So it's 2 . So if you isolate this, we get this divided by 2. That's what I have here.